All right, let's dive into the story of a surprisingly important element, manganese.
We're going to solve a huge planetary mystery, and it all starts right here with this question.
So our first clue seems totally unrelated. We're talking about super strong steel.
This stuff is wild. It's called Hadfield steel, and it gets harder the more you hit it.
How's that even work? Well, a big impact hardens the surface, but the core stays tough. That's why it's perfect for things that just take a constant, brutal beating.
All right, clue number 2 takes us way back and deep down to the bottom of the ocean.
See, people have used manganese for thousands of years, way before we even knew what it was.
The ancient Egyptians used it to clear the green tint from glass. They called it glassmaker's soap.
But way below the waves, another clue has been forming, very slowly.
These are manganese nodules on the ocean floor, and they grow, well, you won't believe how slowly.
Just 1 to 10 millimeters per million years. That's one of the slowest things ever recorded.
Okay, for our last clue, let's jump back to something you probably use every single day.
It's inside your batteries. That manganese dioxide is a super important part of them. And it's becoming a game changer for EV batteries, making them cheaper and way safer.
Okay, so we've got tough steel, ancient glass, deep-sea rocks, and modern batteries. What's the connection?
It's time to solve the mystery, and the answer is actually found in the most important chemical reaction on Earth. It all comes down to this, the oxygen evolving complex. It's a tiny engine inside plants. So, here's the problem. Splitting water is ridiculously hard. It's a super stable molecule.
So how does life do it? With a cluster of 4 manganese atoms that act like a tiny battery.
And this is the big one. Literally every breath of oxygen you take was made by this process.
So yeah, this simple metal, it's the engine of our entire breathable world. It's the invisible architect of life as we know it. Absolutely wild, right? So here's a final thought for you. Photosynthesis makes oxygen. But where does that O2 times really come from?